Today's lesson in science is over acceleration. The lesson and vocabulary skills we will be learning today are about acceleration, that definition, that it does entail changing of speed and direction. That should sound familiar from velocity, and also calculating the equation of acceleration. So let's get started.
Thanks for stopping by. I'm Virgil Ricks, and this is 2-Minute Classroom. Today we're talking about motion. Specifically, we're talking about speed, velocity, and acceleration. And let's clear up a few things right off the bat. First of all, speed and velocity are different, and acceleration is much more than just speeding up. Speed is the rate at which something changes its position. It's represented as distance over time. Miles per hour, kilometers per hour, meters per second, these are all examples of the units for speed. So if you're driving in your car at 72 miles per hour, then that's your speed. In fact, it's your instantaneous speed, or your speed in that exact moment. If you get to the end of your trip and realize that it took you 2 hours to drive 120 miles, then your overall speed was 60 miles per hour. And this is also known as your average speed. Velocity is a lot like speed, except for one important difference. It's a vector, which means it has a direction attached to it. So while your speed may have been 72 miles per hour, your velocity was 72 miles per hour east, or 72 miles per hour towards the beach. There just has to be some direction attached to the speed to make it a velocity. With that knowledge in hand, you're now ready to understand acceleration, which is simply the rate at which velocity changes. It's represented as distance per time, or distance per time squared. For example, meters per second squared are common units for acceleration. Anytime you change your velocity, you are accelerating. That can be speeding up or slowing down, which is also known as negative acceleration. But direction is also a component of velocity. So when you change your direction, even if your speed doesn't change, you are accelerating. Does that blow your mind? All right, let's recap. Speed is the rate at which something moves, distance over time. Velocity is speed with a direction, so distance over time with a specific direction. And acceleration, the king of them all, is distance over time squared, or the rate at which velocity changes. So whether you're speeding up, slowing down, or changing directions, you're changing your velocity and thus accelerating. Science is...
So suppose you are a passenger in a car stopped at a red light. When the light changes to green, the driver steps on the accelerator and the car speeds up, or we call it accelerates. Now that's everyday language. When we hear the word accelerate, we think of just speeding up. So we think of it, when we hear it in regular terms, in regular people terms, we just think of it as the process of speeding up. But I need you to think like a scientist. So if we think like a scientist, acceleration has a more precise definition. Of course. Scientists define acceleration as the rate at which velocity changes. Now, remember velocity from our last lesson. It entails both speed and direction of an object. As mentioned previously, a car that begins to move from a stopped position or speeds up to pass another car is accelerating. If there is a change in speed, so we're down to speed, that part, either speeding up or slowing down, it is called acceleration. But one thing that many people don't think of is that acceleration also is, if it has direction, that can be also considered acceleration. So that's the second part here under acceleration, changing speed. We're now on the second part of that. The second part of changing directions states that even an object that is traveling at a constant speed, so an airplane on autopilot will stay the exact speed, a constant speed, it can be considered accelerating if it changes direction. Recall that acceleration can be change in direction, in speed, or both. That's in the scientific terms. So let's look at a recap here. It can be speeding up to be considered accelerating, slowing down, changing directions, or any combination of these three things. If it has any one of those things, it would be called accelerating.
When we are in a stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you two examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers an hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers an hour. In which case do you think acceleration is involved? None. In both cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity. Do you remember what velocity is? It's speed with direction, and it's hence a vector quantity. Why is this important? Let's say a body moves from rest and reaches a velocity of 20 kilometers an hour in 5 seconds. Will acceleration be involved here? Yes, because the velocity is changing. It was 0 initially, and at the end of 5 seconds, it's 20 kilometers per hour. In another scenario, assume that a body is moving at 30 kilometers an hour, and then it moves right at 30 kilometers an hour, and continues traveling at the same speed of 30 kilometers per hour. Will there be acceleration in this case? The answer is yes. As the direction is changing, the velocity will also change. The only thing constant in this example is speed, but the velocity changes as the direction changes. So this was the most important concept you had to know about acceleration. It will exist only when there is a change in velocity. But how is acceleration calculated? Acceleration is defined as the rate of change of velocity. In terms of a formula, acceleration can be written as change in velocity over the time taken. If the velocity of an object changes from an initial value of u to the final value of v in time t, then the acceleration a can be written as v minus u over t. Say this object is at rest initially at point A. It then travels to the right and attains a velocity of 10 meters per second in 5 seconds. What will be the acceleration here at point B? We can look at the formula to get the answer. The initial velocity u is 0 meters per second as the object is stationary. The final velocity v is 10 meters per second and the time taken t is 5 seconds. Hence, the acceleration a will equal 10 meters per second minus 0 meters per second divided by 5 seconds. So this will equal 10 meters per second divided by 5 seconds. 10 divided by 5 is 2. Wait, hold on. What will be the units of acceleration? We should get a hint by looking at this. The units of acceleration will be meters per second, because it's the change in velocity over the time taken. As this is meters per second, we can carry this second to the denominator, and what we will get is meters per second squared. This one is more intuitive, but this one is a bit neater, I would say. So the acceleration in this case will be 2 meters per second squared. And acceleration is also a vector quantity. Here, acceleration and velocity are in the same direction. There are many more important concepts about acceleration which we will cover in the coming videos.
Okay, so calculating acceleration can get confusing. So the previous video did go through that a little bit, and I wanted to go through it again because it is a little bit confusing when you throw in a new formula. So let's look at the formula again and wrap things up by having some additional practice with another YouTuber called Dr. Oz that will go through a few more examples. The formula is acceleration, which can be represented as A. That equals the final speed, which we will call F, minus, which is the minus sign, the initial speed, which we will call I, and that is divided by or over, that the line indicates the division. So we've got our formula here, over the time, which we will represent as T. All right, so let's keep that in mind as we watch this final video clip with some examples. Good luck.
Hello, I'm Mr. Oz, and in this recording I'm gonna show you how to solve simple acceleration problems. Let's start with acceleration. Acceleration means change in velocity per unit time, which means that if an object is accelerating, its velocity is changing, either increasing or decreasing, or its direction is changing by time. So, we can use this formula to calculate acceleration. And if we use the symbols, we can rewrite the formula in this form. Here, A represents the acceleration and its unit is meters per second squared. V and U both represent velocity. V is the final velocity, U is the initial velocity of the object, and T is the time taken. Let's see how we use this formula on a problem. In this problem, there is a man moving on a straight line, and he will speed up from 2 meters per second to 22 meters per second in 4 seconds, and we are supposed to find his acceleration. So basically, his initial velocity is 2 meters per second, and his final velocity is 22 meters per second after 4 seconds. Let's use our formula to answer this question. So here V represents the final velocity and U represents the initial velocity, and T is the time. If we do this calculation, we can find the acceleration as 5 meters per second squared. Now it's your turn. By using the same formula, can you answer this question? Okay, here's some hint for you. There's a car, it's moving on a straight line, and you know its initial velocity, and you know how long will it take for him to reach point B. It's 5 seconds, and you're looking for its final velocity. You need to know the acceleration. He has a steady acceleration of 3 meters per second squared. Good luck.